We did that first derivative using implicit differentiation. Then, from the first derivative, we're going to do the second derivative. To do that, since it's negative x divided by y, we're going to have to use a quotient rule. Low d high minus high d low over low squared. However, dy dx is a weird term to have in there. We know dy dx is negative x over y, so we're going to replace dy dx with negative x over y. To simplify my life up here, nobody likes fractions inside of fractions. Now you can get a common denominator and flip and multiply. That would work wonderfully as well. A clever thing to do is multiply by that denominator on top and bottom. What that does, now it does distribute. It gives you negative y squared minus x squared. This y cancels over y cubed. And then common trick that AP will always play. They will always do this. So look for it. This is also a hint on the bonus problem. Look for it. The original equation happens to appear again in the second derivative. Well, what is x squared plus y squared? 10. And so they replace it with that. Look for that. One number, what's the one, the cosine and the EX? What's that one? Use this trick. Use this trick. E to the y equals sine of x, right? So this trick, what number is that? Number 6. This trick will help you with number 6. This trick will help you with the bonus. If you wish to do the bonus, you notice it's a whole homework assignment. There's a reason it's a whole homework assignment. It's a good. So it's there. If you want to do that, you don't have to. Okay. One new item for today. Tangent line approximations. We haven't actually done a lesson on tangent lines. You are pretty good at them. But there's a word you need to know, and it's called a linear approximation. If you read the word linear approximation, in your head, change it to tangent line. If you read linear approximation, change it to tangent line. Turns out, now in Cal 1, you won't get the full scope of how this is useful. But it turns out that sometimes tangent lines do a better job of approximating values on curves than the actual curve does. And so sometimes tangent lines will be used. One, they're easier. Two, they're sometimes better approximations. So in the long-term future, later in your life, a tangent line can be used to approximate the value of a function if you're close to where the tangent line was. So for example, if I'm looking at this tangent line here, I can use the tangent line to approximate values close to that point, because it's going to be close to the curve. Does everyone see that? Now, if I'm talking about the tangent line at 2, would I use that to approximate 5? Oh, that one's a bad example, because it crosses again. Would I use it to approximate something down here? That would be a horrible idea. Only something that's close. So how that's going to be worded on the AP exam. Use the tangent line at x equals 2 to approximate f of 2.1. Well, to do that, I need to find a tangent line. What are the 3 things I need to find a tangent line? Three things. To write an equation of a line in general. X, y, and down. It tells me to find that tangent line at 2. I need to find the y value at 2, so I plug 2 into the equation. 2 cubed is 8. So 8/3. Minus negative 1/3. Is that right? You should check that. So that's the y value. how do I find the m, the slope derivative? And I'm going to plug in 2 into the derivative. 2 squared, which is 4. 4 minus 2 is 2. So my tangent line is that right there. Any questions so far? Writing the equation of the tangent line. Are we getting pretty good at that? The only new information today is how to use that to approximate. Well, it says to approximate f of 2.1. I'm going to plug 2.1 into the tangent line and find y. .1 times 2 is 0.2 minus 1/3. 1/5 minus 1/3 is negative 2/15. Y'all better check that. I think that's negative 2/15. Do what? So the approximation is negative 2/15. So f of 2.1 is approximately negative 2/15. Using the tangent line to give us an approximation. Any questions about that? That is the only new material for the day. Any questions? Good? I'm going to pass out the quiz and I'm going to pass out a worksheet. It is a tangent and normal worksheet. It's actually one we skipped to do implicit differentiation sooner so we could get to the gateway sooner. So it will almost feel too easy at this point, and that's okay, but we still need to make sure we can do all of it. So tangent line today. Yes. I am going to post this full video from last semester. Today I shortcutted it quite a bit so you could get through it. I don't think you'll need to watch it, but if you do, it will be available. There are a couple more examples on it, a couple little tangent line examples, but we've done things like them already. Like, where does f of x have a horizontal tangent? Things like that. So if you want to watch the video, it will be available, but it's not something that I'm saying you have to go do. Only if you get stuck on the homework list, unless you want more help with tangent lines. Other than that, just the worksheet that, yeah, and then implicit. The one that you've been working on. You should have a bonus problem left, maybe. Yeah. I hope you're done with it for the most part. It's, yeah. I wanted to give you that bell ringer to help you with the bonus in case you wanted to do the bonus. Other than that,